Hello, so I'm Viktória Fördős and I work as an Erlang engineer at Cisco NSO Core. I solve network orchestration problems in Erlang every day. You know, I've been interested in the security of the beam for a while. This has become my hobby, so to say. My questions have been, what support does Erlang OTP provide? What are the challenges left to the engineers? How can one release a secure software product? What are the pitfalls? And what are the methods and tools we have today? So let's start with the platform support. And let me quote what Joe Armstrong wrote in the history of Erlang paper. Our idea was to connect stock hardware through TCP IP sockets and run a cluster of machines behind the corporate firewall. We were not interested in security, since we imagined all our computers running on a private network with no external access. This architecture led to a form of all or nothing security that makes distributed Erlang suitable for programming cluster applications running on a private network, but unsuitable for running distributed applications where various degrees of trust are involved. Well, this is not how we use Erlang Elixir today, right? So yeah, there are a lot of challenges waiting for us if we want to deliver secure software. Well, who doesn't? This is one of the most basic obligations of any company, or should I say, any software engineer, right? So there are high-risk vulnerabilities in Erlang that we should be aware of. And we can group them using the CIA triad model. It's a modeling tool from InfoSec, let's say. So the first group is confidentiality, which contains vulnerabilities that, if exploited, the confidentiality of the system is compromised. We say a system has confidentiality if information can only be viewed by authorized parties. Since neither SSL nor crypto is shipped with the secure configuration by default, you have work to do. You need to pay attention on how to configure and use your libraries. The second group is integrity. We say a system has integrity if the information is not unexpectedly modified. Now, how can this happen in Erlang? So the host or the Erlang VM can get unexpectedly modified if a remote code execution attack takes place. So think about the OS command, the port commands, and various functions allowing runtime evaluation. Those can be easily exploited. And then we have the third group, availability. And we say a system has availability if information or resource is available when needed. Now, of course, all vulnerabilities listed in the previous group can be considered here as well, right? So if the remote code execution attack is about to compromise the availability of the system, then, well, yes, then they belong here as well. But there are more, unfortunately. So in Erlang, there are system limits, like maximum number of atoms and ETS tables. So when you exceed these system limits at runtime, you are going to crash the system. So the VM is going to go down. And well, Erlang is not immune against memory exhaustion attacks either. So let me highlight, this is not only about the any to atom calls. It can be the creation of ETS tables as well, or overloading a generic TCP UDP listener process with a large TCP UDP packets, right? So as we see, there are multiple functions in Erlang OTP that we need to use with care. But does it mean that we need to avoid them at all costs? Does it mean that from now on I shouldn't use ETS tables and I shouldn't create any Or converting a list to atom is banned because all list to atom calls are evil. Or is it really that I should avoid using OS commands? And then on the other hand, if you look at this line of code, ETS new user, there is literally no problem with that. This line of code is going to create an ETS table named user. So you see, this is not black and white. Not all the use cases are evil. And these functions are here to allow us to develop the system we want to develop. So the question becomes, what use cases of these functions are risky? What use cases can compromise our system from the security point of view? And how to decide on that? This is the big question now. And I think if you start thinking about this at the development phase, then it's a bit already too late. You don't have the prior knowledge that will help you make these decisions. So what I think is that what we need is a systematic method that ensures that security is a first-class citizen at all phases. And so, for instance, there is a secure development lifecycle, which is a software development methodology, and it really highlights and emphasizes security at all stages. So how it goes is that at the design phase, at the planning phase, we want to identify the security requirements, the trust zones. We want to perform threat modeling. And then at the development phase, we will use this knowledge and then secure coding standards, vetted common security modules. We will do, of course, code reviews, right? And then we are still not done because before we launch, we need to validate and we need to do vulnerability testing. And then at launch, we will need to review again the security requirements, the threats, and the vulnerabilities. We need to be up to date. And well, we need to keep doing that until our product reaches end of life. So you see, security does have a role at all phases of software development. And this is very generic, what I'm telling you. But the question is how to do this in Erlang. And in this presentation, I'm going to show you a way. So let's begin. Now, let's look at the planning phase first. As a reminder, at the planning stage, we identify the security requirements and we perform threat modeling. So what our goal is that we want to understand our system very, very early as possible at the design phase. We want to identify the actors and the components of the system and the interactions among them. What we need to be really, really cautious about is the incoming data. I mean, we have an expectation of what our component receives, but what happens if it receives something else, right? We are going to execute something very different and we may become victim of batch injection as well. I mean, yeah, so knowing your system and identifying interactions between the components are really important. And threat modeling can help you to find and focus on the most critical flaws in your system. What I suggest is that you work with trust zones. So trust zones help you decouple your entire system into, I don't know, a dozen components, a dozen blocks, like trust zones. And then inside the trust zone, we have interacting components. So as a general rule, components inside the trust zone have trusted relationships among themselves, and then they can exchange information with each other without the need of data control. They can trust the data and assume that the data is not tainted. But data entering the zone, however, must be considered tainted. So any data entering the zone from another component that's outside of the zone, right? That's untrusted. So, and then when data enter the zone, that we consider tainted. And we need to validate it as soon as possible or when it makes sense, right? And you see, taintedness is kind of contagious, because if you create another data using the tainted data, then that becomes tainted as well. And the antidote against taintedness is validation and sanitization. Now, if you think about this, if we work with trust zones, we are going to see the interactions among the trust zones. We are going to see the incoming data into a trust zone. And we are going to focus at the trust zone boundaries. And well, that's where the system is the most vulnerable. So we are going to see what external entities the trust zone interacts with. And based on the interactions, we will be able to identify the threats and mitigate them. Now you can ask me how to choose trust zones in Erlang. And well, I would say let's start with the unit. So our choices are Erlang modules, applications, releases, or the host running the Erlang VM. But let's exclude the host immediately, because you can deploy multiple Erlang VMs on the same host, so it's really not fine-grained enough. This leaves us with the largest meaningful unit to be the Erlang release. So if you consider the Erlang release as a single trust zone, you will see the connection between the verb and your system. You can discover the interactions, data flowing into your system. This is a very, very useful knowledge. But if in your system you have multiple components that operate with different privilege levels, then maybe this is not enough, because you are going to lose the boundary between those two components, and you won't remember the development stage to have data control there at the borders. So I argue that the best choice is a single or a set of Erlang applications together with their application dependencies. Erlang applications are the reusable units of the Erlang ecosystem. You can bundle them into multiple releases or be part of different deployments. And remember, an Erlang application consists of modules and processes started by that application. Now, how to work with the units? So I think we have two choices: either start from the largest meaningful unit, an Erlang release, and iteratively decompose the trust zones, or start from the smallest meaningful unit, an Erlang application, and iteratively join the trust zones together. Now, if you go with the joining approach, then you are going to get your main components safely reusable, which is nice, because then in your next project, you can just pick a trust zone from your previous project, and then you can use it, right? All right. So now we know what are our trust zones and how to identify them. So the next thing is, what are the entry points of a trust zone? Considering that a trust zone is a set of Erlang applications, I think it's not really a realistic expectation to consider all exported functions of all modules of a trust zone as entry points. I mean, it's going to be a lot of functions, a lot of entry points, and they are not all relevant. So, and if you think about it, in practice, a valve-written application specifies its external API in a very few modules. So if the application is not misused, then all incoming data should flow into the applications through those modules. So the exported functions of the API modules should be considered as entry point, but we are in Erlang, right? And data can enter into our component not only by function calls, we have message passing in Erlang. And we should consider messages entering the zone as tainted data as well. But what messages should we consider? So if it's a component and the way to interact with that component is by message passing, then that's some sort of well-defined protocol, right? And I would argue that there are a little of these receive clauses, and they are usually in some kind grouped together in an API module. So I think the entry points, what we should consider are the exported functions and the receive expressions of the API modules. Great. Now we finally can formulate what we want to avoid at all cost. Data entering a trust zone through one of its entry points and flowing into a high-risk vulnerability of Erlang OTP without any sanitization. This is what we want to avoid at all costs. This is where we need to focus. These are the most critical flows in our system. You know, it's common to have a few OS calls in any Erlang system, and there is no problem with that, while the arguments are independent from user inputs. Now let's see an example why knowing trust zones and entry points are super important. Let's see what happens when we don't do our homework at the design phase. We don't know what are the entry points of our trust zone and where and what data can flow in. Okay, so let's say we have a component in our system that's responsible for user handling. Whenever a user arrives to the system, it performs some initialization, like loading the user cache to memory, ensuring the workspace of the user present on the file system, and start some user processes. And the ensure user dir function is implemented as follows. Take the username given as input and ensure that a directory named after the user exists in the root directory. Our engineer knows how to do this in Unix, right? It's mkdir-p, and of course knows about OS command. So the implementation of this function becomes calling OS command with a prepared string. Great stuff. If the user variable is the wiki string, this works as expected. If the user variable is the hello atom, then this is going to crash. Fine by us, right? Let it crash. Great. But if the user is the following string, semicolon, rm-rf/, something terrible is going to happen if the OS user running the beam is powerful enough. So let's say the worst thing happened, option 3, and all our hard disks have been wiped, and we are now at an incident retro, and we are trying to identify the problems, the root cause. And well, we had multiple problems here. The first problem is coming from the design phase. So what happened is that our component blindly trusted data incoming from another component. How come? Well, we never specified that the user variable is an incoming data, right? So we didn't do our homework, and the engineer assumed that the user variable has already been sanitized. And if we think about it, we don't sanitize all input of all exported functions in our code. Now the second problem is an implementation problem, because OS command was used, and OS command is a very, very powerful tool, and it was used without any caution and without any real need, because there is a function in the file module called makedir that is much less powerful, and if we follow that secure coding guideline, that we don't use too powerful tools if it's not necessary, then, well, we are in better shape, right? But there was a third problem, and that problem happened at the development phase, because we had a very, very big deployment that gave enough rights to the OS process running the beam to execute the operation. So you see, we had problems at the design phase, develop phase, and deployment phase. So now I hope I convince you that it makes sense to do your homework at the design phase, because then you can avoid like incidents like this. And now let's focus on the development phase. And so at the development phase, we use the knowledge we gained at the design phase. We are going to we know what are trust zones. We know what are the tainted data. We know what is the incoming data, and so we know the most critical flows in our system. And now in the development phase, we are going to use secure coding standards like MCAT, like using the file makedir instead of OS command. We will use vetted common security modules, so we don't implement our own SSL, and we will do code reviews. So if we go back to our example, then now we know that the user arrived function is an entry point. So we know that the user variable is a tainted input. It's an incoming data entering the zone. And what we want to do, we want to validate the data and allow it into the zone if and only if it is valid. So what I show on this slide is a very brutal way of sanitization, because we simply crash if the value of the user variable is not valid. Now, of course, there are times when you want to be more soft and more forgiving, and you want to sanitize instead and allow the sanitized version to continue its flow through your trust zone. So if you look at this slide, we have two variables here, user 0 and user, and it's only user 0 that is tainted, because user is the result of the sanitization. So that is safe. Now, even if we do our best at the development phase, we still want to validate our software product. So we want to verify that it is secure before we release. To do that, we do a security review of our code. Now, what we are going to do is the following. We are going to follow the data entering the zone through its entry points. We remember when it enters, it's tainted, and then any expression created using the tainted data becomes tainted as well. And what we do is that we follow all those data through our trust zone. We can stop following those data when they got validated or when they get sanitized. But if we find a flow where tainted data flows into a high-risk vulnerability of Erlang, then, well, we found a high-risk vulnerability in our system. And regarding this manual approach, well, it's very, very trying and really error-prone. It's super easy to miss one flow of the data, and maybe that was the important one. So what would be really nice to have is some tool support to carry out this task, right? And here research can help. Using static methods, we can identify and follow tainted inputs. So let me show you a static analysis I created to analyze a trust zone. So as input, we take the modules containing the entry points of the trust zone, and then we calculate the entry expressions by selecting all expressions from the exported functions heads and all receive clauses defined in the modules given as input. Then we use data flow analysis to follow the value of the entry expressions and see where they reach in the trust zone. It's basically what we do manually, but here we use data flow analysis. And if an input reaches an listed vulnerability, then the analysis must record it and output the file and position information of the entry expression and the found vulnerable and the reached vulnerable function. So what we are going to show is the beginning and the end of the chain. It is a path of a possible exploit. I implemented this static analysis as a prototype on top of refactorer. So it's a prototype, so be kind to me. Anyway, so refactorer is a static source code analyzer and refactoring tool for Erlang. It does have the regular static analyzers, but it does include Erlang specific ones, like process analysis, message passing analysis, dynamic function call analysis. And this is very great because the more information is available, the more precise the data flow analysis will become. Right, going back to the prototype. So you can download it from the GitHub. And what's going to happen is that at build time, it will download refactorer as well and compile both for you. I as well tried it out, right? And how I tried it out is that I chose an open source project, and then I analyzed it manually and with the tool, and then I compared the results. So the tool found all the vulnerabilities I found by hand, nice, but it found the ones that I missed. And I was so focused, but I still missed some. So yeah, try it out. But you have other tools you can use. So there is PAST. It's a grep-like tool. It doesn't use any static analysis. So the result will be incomplete because it's likely it's going to miss instances of vulnerable functions and will return you false positives, not real vulnerabilities. So it's fast, but it leaves a lot of work on you. Then there is the trust zone analyzer tool I showed you. So the good thing is that it uses static analysis and it's going to minimize your false positives, but you will need to know what are your trust zones and entry points. So there is a requirement that you need to fulfill before being able to use the tool. But well, if you ask me, I think you should know this anyhow. Then there will be an upcoming release of refactorer, so I heard, where they will release their built-in analysis. They don't have the notion of trust zones, so they will give you much more result by default because they will analyze all exported functions of all modules. But there are ways to configure their analysis so you can narrow down the result set. And well, they have a very nice GUI support, and from there you can run the analysis per function, which is quite nice. And then you have another option as well to write your own XREF queries. Yeah, I have a few more notes that I would like to share with you. One thing is that in Erlang or in Elixir, it's really easy to use third-party libraries. It's just super easy. But you should not forget that you cannot assume it is secure. You need to verify the security posture of those dependencies as well. And then another thing is that in the outcome of Erlang projects are very diverse. It can be an application, it can be a release, and therefore it's very easy to lose the focus or lose the ultimate goal, which is that the thing that you release, let it be an application or a release, it must be secure. And well, finally, I think you should be nice to your users and give guidelines on how to deploy your software product. Like, what are the security related configurations of your product? What needs to be considered on the deployment host, like the privileges of the OS user running the Beam. The Erlang Ecosystem Foundation created a very nice guideline, and you can see it on the slide, and I think you should check it out, read it. It's very useful. Okay, so as a summary, I hope I convince you that having a constant focus on security during the whole development life cycle is super important, and it's going to pay back. But you need to have focus starting from the design phase. I think if you start from the development phase, it's a bit too late. And well, you know, security is not a one-time task. It is supposed to be a recurring process. Well, good luck to you and thank you.
Great. Thank you so much, Viktória. Lots of applause. So any questions, please, for Viktória about the security, Erlang development, Beam? I suppose I will start with one question. So you were talking about following tainted data, and I was wondering about your thoughts regarding storing this kind of data permanently, temporarily. Any thoughts on that?
Yeah, so that's a very interesting thought, because just storing the data, that's not really risky, right? I mean, I write it in ETS table, or I write it in Media, that's all right. But if we don't validate this data before we write it to our storage, then whenever we read data from that storage, well, the thing is that then you need to validate it. So I think then it becomes a question of, do you want to validate before you write, or do you want to validate every time you read? And I would vote for the writing. I think you should validate at that time. Does
right.
it?
Yeah, great. Thanks a lot. John, could you help me? Because I don't see any questions or posted anywhere. Do we have questions, just in case I don't see them anywhere, or raised hands?
And normally within the chat on a session Q&A, which is on the agenda.
I just didn't see anything there. So I'll proceed with another question then, and that was about, again, tainted data. So sorry for bombarding you with that. And so regarding tainted data, I was wondering about overheads. So how expensive is that? Because we were talking about following the data, then following until they're validated, until they're sanitized. So what overheads should we expect in terms of performance?
Right. So when you do the security review, that's not part of your product, right? That's part of your development methodology. So how I would imagine, what I would like to have is that the security checkers becomes part of the CI/CD pipeline, so that before we get a green Jenkins run, so to say, we do run our security checkers as well. And well, I mean, the more precise you are trying to be, the bigger the source code is, most likely the analysis is going to run longer and longer, right? But I think the thing is that it is very easy to say that, this was just a one-line chain, nothing happened. But maybe that one-line chain connected components in a new way, and then they inserted that tainted data into that component, and that was previously not present there. So I would argue that you should really do it every time before you try to merge something. So have it part of the PR review process, so to say, the pull request review process. But yeah, you would like to have some lightweight checks, I think.
Right, great. Any questions from audience? Because I have more questions. I can actually bombard Viktória for quite a while. Right, so I will go with my final question. We have 3 minutes to go, and I'll have one more question. So you were talking about security during the development, right? So during all the stages, design, requirements, and everything. I was wondering about your thoughts, security in the language itself.
Yeah, that would be really nice to have a way maybe to generate some checks right into our source code. So for instance, that's very interesting. So what comes to my mind is how nice would it be that we write specs for all exported API functions usually, or we tend to do that. And how nice would it be if we could take those specs and then we could generate some basic checks, generate code and then have our source code transformed. But I wouldn't say this is going to be the silver bullet, so to say, because if we think about the example I showed, I showed that it was Vicky who was what was the value of the user first, right? And that's a string. So then we could test that. Okay, is it a string that's entering the zone? But the problematic value, that was the OS command, the bash injection, that was a string as well. So that with type checks, I'm afraid we can't really do 100%. So we always need to keep the security experts in the loop, and we need to use our head. At the end, it's going to be the software engineer who is going to be the best defense of the company.